Welcome to Maths Video Tutorials, and welcome to this tutorial. In this tutorial we will be taking a look at the modulus function, and we're going to start by taking a look at the absolute value. A good example to illustrate an absolute value is to take the example of a vector. When we calculate the magnitude of a vector, we use absolute value. For example, if we have a vector that is 4 across and 3 up, and we want to calculate the magnitude of this vector, we use 2 vertical bars on either side of the vector. This is absolute value, and it will return a value of 5. So you can see this absolute value will return just the value 5 without any sign. If you apply this to a -2, so if we do an absolute value of -2, it will return just the 2, the value of 2 without the sign. If we do an absolute value of +3, it will return a value of 3. And if we did absolute value of 0, it will return a 0. So now we can go ahead and define an absolute value. So if we take the absolute value of x, it will return x if x is greater or equal to 0, and it will return -x if x is less than 0. How about if we take another expression? So let's say we want the absolute value of 2x minus 1. It will return 2x minus 1 if the expression 2x minus 1 is greater or equal to 0. And this will give us the inequality x greater or equal to a half. It will return -2x minus 1 if the expression 2x minus 1 is less than 0, and it will give us the inequality for x less than a half. We can now write a more general definition. If we have the modulus of f of x, the definition is that it will return f of x if f of x greater or equal to 0, and it will return a negative f of x if f of x is less than 0. So let's complete this introduction to modulus function by answering this exercise. We have a absolute value of x which needs to be substituted into this function here. Now, since the absolute value of x is equal to 3, therefore x would be equal to either -3 or x equal +3. That's because the modulus of -3 will return 3, and the modulus of 3, of course, will return the 3. So let's do the first one. When x equals -3, we'll substitute it into the function f. So we say f of -3, and we plug it into this modulus here. 3 times -3 plus 5. And that will be equal to modulus of -4, and that will return a value of 4. For this one here, f of 3 is equal, we plug in into the expression again, similar to what we did earlier, or just now. That will give you a modulus of 14, and that will return a value of 14. Alright, with that, we completed the introduction to modulus function. Next, we have a look at sketching the modulus functions or modulus graphs. So let's have a look at it. So for this part of the video tutorial, we're going to look at the sketching the modulus function. We will start by sketching the modulus of a linear function. We do this one here, and then we do the modulus of x only, so this one here, and then we do the same thing for the quadratic. So we draw a normal quadratic graph, and then we draw the modulus of that graph or function, and then we draw the modulus of the x only. This is the modulus of x. Sketching modulus function is not limited to these two graphs, linear and quadratic only, but it will be a start. So let's get started with the first one. When sketching a graph of a modulus function, it is a good idea to sketch the original function first and then follow these rules here. So if we are sketching the graph of modulus, the whole function f of x, then we need to reflect in the x-axis. And if we are sketching the graph of the modulus of x only, then we need to reflect in the y-axis. So these are the two rules we need to follow, and they apply to any form of graph. So let's do the first one here. So basically the positive part of the graph is this one here, we need to keep. The negative part of the graph, this one here, we need to remove. We don't need this one here. So any point that is on here, on this part, on the negative y-axis, will be reflected on the positive y-axis. For example, this point here will reflect onto here, and then we draw our graph. So we remove first the part that we don't need. So I need to remove this one here and then draw my graph like so. Now for this one here, the part I don't need is this one here, because this part belongs to the negative x-axis. So basically all these x coordinates will be reflected onto here. So this one has to go up to there, and then from this point here, we reflect along the y-axis. Now to be accurate in your reflection, just pick this point here and reflect it onto here, and then join the 2 points here, these two here, and that is your sketch completed. All right, let's do a quadratic one now. Now we can continue with sketching modulus for graphs, this time with quadratic graphs. The method will be the same. So we sketch the original graph and then we apply the modulus rules. For this one here, we need to reflect in the x-axis. So basically this is the negative part of the graph, and this one here. So these two will have to go, and we reflect them on the x-axis. So if I do this one here, roughly it's going to be just like that, okay? And this one here is going to be like that. And always make sure the negative part, you have to rub it off from your graph. Okay. And for this one here, we're doing the modulus of the x only. All right, so anything on the negative x-axis has to go. So all this has to be rubbed off, and we reflect this part here in the y-axis. All right, so let's do that. It's going to be pretty simple. So what I'll do, I'll try to do this one here, and hopefully I get it right. And this one here will reflect here as well, the maximum, the turning point, so something like that. All right, so that's how you sketch a modulus of quadratic graph. And again, just to remind you, this method or this procedure apply to any form of graphs. Thank you for watching, and take care.